Now, in this short presentation, I'll discuss the functions, sources, requirements, and issues with deficiencies for the vitamins folate, B12, and vitamin C. Now, let's start off with talking about folate. The word folate is used to describe a variety of forms of this B vitamin that's found in foods and in your body. You may also hear it called folic acid, which is the synthetic form added to fortify foods and the form present in dietary supplements. Now, the key role of the folate coenzyme, tetrahydrofolic acid, or THFA for short, is to supply or accept single carbon compounds. Now, in this role, THFA helps form DNA and metabolize amino acids and their derivatives, like homocysteine. THFA transfers CH3 to homocysteine, which forms methionine. The formation of methionine is very important since high blood homocysteine levels have been associated with increased risk factors for cardiovascular disease. Now, the actions of folate and vitamin B12 are often interrelated, and interestingly enough, when B12 is unavailable, folate cannot be absorbed by the body, and a deficiency can occur even if you are consuming plenty of folate in your diet. The name of the vitamin folate is derived from the Latin word folium, which means foliage or leaves. So it makes it easy to see that the main food sources are mostly leafy green vegetables. Also, orange juice, dried beans, organ meats, and other vegetables are good sources of folate. Folate is easily destroyed by heat, oxidation, and UV light. But vitamin C in some food sources of folate, like orange juice, helps to reduce the destruction of folate. But unfortunately, food processing destroys 50% to 90% of the natural folate found in food. Now, the RDA for folate is 400 micrograms per day, but that number is increased for pregnant women to 600 micrograms per day, and you'll see why on the next slide. And it's increased to 500 per day for breastfeeding women. The upper limit for the synthetic form, folic acid, is 1,000 micrograms per day. Now, why is an increased amount of folate important for pregnant women? If folate consumption is low, neural tube defects may occur. Now, the neural tube is what turns into the brain and spinal cord in a developing embryo. The two most common NTDs are spina bifida and anencephaly. Spina bifida is a birth defect that results from improper closure of the neural tube during development. When the baby is born, the spinal cord or fluid may bulge outside the spinal column, and you can see that in the picture to the right. The other neural tube defect, anencephaly, is a birth defect characterized by the absence of some or all of the brain and skull. And sadly, these babies don't live very long once they're born, if they are born alive at all. Most only live a few hours after birth. Adequate folate intake is vital for all women of childbearing age, since the neural tube closes within the first 28 days of pregnancy, this being the time that many women are not even aware that they are pregnant. Okay, another result of folate deficiency is that in early phases of red blood cell development, immature cells cannot divide because they can't form new DNA. Now, the cells get progressively larger since they still can't synthesize enough protein and other cell parts to make new cells. Now, when it's time for the cell to divide, the cell does not have enough DNA to form two nuclei, so the cell remains a large, immature red blood cell called a megaloblast. And you can see a picture of this on the left-hand side of this slide compared to a normal red blood cell on the right. Now, when a person is producing mostly immature megaloblast cells, the capacity of the blood to carry oxygen is clearly diminished, causing a condition called megaloblastic anemia. And since folate deficiency interrupts cell division throughout the entire body, other issues that can arrive with folate deficiency is that a person may experience tongue inflammation, poor growth, cognition issues, diarrhea, and nerve function problems. Now, moving on to vitamin B12 or cobalamin, B12 is an interesting vitamin because it is the only one with a mineral as part of its structure. Its coenzyme participates in many cellular processes, most notably the transfer of CH3 groups and folate metabolism. Now, like folate, B12 is also needed for the homocysteine metabolism. B12 is needed for the maintenance of myelin sheaths that insulate nerve cells, but it does this independently of folate. Sadly, deficiency can result in death, so it's really important to get B12 in your diet. Good food sources of B12 are liver, meat, milk, and milk products, poultry, fish, shellfish, and eggs. In order to absorb vitamin B12, the vitamin must be released from the animal protein to which it is bound. Now, the only way this can happen is through the action of hydrochloric acid in the stomach. Now, once it is separated from the animal protein source, vitamin B12 binds to a compound in the small intestine called intrinsic factor, which is produced by certain cells in the stomach. Once bound to intrinsic factor, absorption of B12 can occur by the body. The RDA of B12 is 2.4 micrograms per day, and because plants cannot make vitamin B12 and it's supplied almost entirely by animal products, B12 deficiency is of particular concern to vegetarians and vegans, so they have to be sure to include B12 fortified foods in the diet. Most cases of B12 deficiency result from problems that interfere with intestinal absorption of B12. It's mostly due to issues not with the intake of B12 from the diet, but with the release of B12 from the animal proteins itself. Now, because most people who have problems with this type of malabsorption still can produce the intrinsic factor, dietary supplements of the synthetic form of B12 can be used to increase absorption. There are yet others who have an autoimmune disorder that can halt the production entirely of intrinsic factor. This prevents absorption of B12. And it leads to a condition called pernicious anemia, which can cause nerve damage and megaloblastic red blood cells. B12 injections can help overcome this issue and help those who suffer with this begin to absorb the vitamin without the need for intrinsic factor. Now, moving on to the last vitamin I'm going to cover in this presentation, vitamin C or ascorbic acid. So it's obviously not a B vitamin like the others discussed in this presentation. I provided a more detailed article about James Lind on the Blackboard site, but Lind helped find a cure for a deadly disease called scurvy. In the 1700s, sailors on long voyages were suffering from bleeding gums, tooth loss, bruising, and scaly skin. And in addition, any wounds they suffered on the voyage would not heal, often leading to death. In 1740, Lind first showed that citrus fruits, 2 oranges and 1 lemon per day to be precise, could prevent scurvy. Even after this discovery, scurvy remained an issue, especially during the Civil War when Americans did not have adequate intake of vitamin C. Now, vitamin C does not function as a coenzyme like the B vitamins, but it does act as a nutrient cofactor that assists in certain chemical reactions. As a cofactor, vitamin C helps with collagen synthesis, antioxidant activity, and immune function in the body. Good food sources, as I mentioned earlier, are citrus fruits, peppers, papaya, broccoli, cabbage, and berries. Vitamin C is also unstable in the presence of heat, oxygen, light, and alkaline conditions. But keeping foods refrigerated can help slow the loss of vitamin C. The RDA for vitamin C is 75 milligrams per day for women and 90 milligrams per day for men, and deficiencies are quite rare these days. However, as antiquated as scurvy sounds, it can still occur now. In fact, between 2009 and 2014, cases of scurvy rose by 27% in England, according to figures from England's Health and Social Care Information Center. The cases were mostly in children that were from either poor families or who were extremely picky eaters. Now, in 2009, in a Massachusetts hospital, ironically enough, a man came in with symptoms of bleeding gums, swelling, bruising, and severe fatigue. One physician thought to ask the man about his diet and found he was from an extremely poor area and had only eaten American cheese slices on white bread for years. Ultimately, he was diagnosed with scurvy. And over the next 5 years, 29 more people came in with vitamin C deficiencies severe enough to qualify to be called scurvy. The upper limit for vitamin C is 2,000 milligrams per day, since taking in more than that can result in GI upset or even kidney stones. Now, that's all I'm going to cover about the water soluble vitamins in these presentations. But I would like you to read about the vitamin like compounds at the end of the chapter and the section on diet and cancer.